Hello, London. Thank you very much. We've got a full house. So, welcome to our talk. We're going to talk about the hidden data behind everyday questions. It perhaps should come as no surprise that two Zen masters are using Tableau to answer questions within the product. But what about the kind of questions we're asking? Well, these are questions like, why is the weather always changing on me versus the weather forecast? These are questions like, why is this shopping centre exactly the same as the one I'm being dragged around last week? Is it really, or is it just look the same? And these are questions like, is Christmas TV really just got terribly bad? Or am I just getting old? So those are the kind of questions we're answering within Tableau. And let's talk you through an example. So have you ever been to a gig and you're sat there watching the band and you wonder, how do they come up with the set lists and the order that they're putting their songs in? Don't know about you, but you always see a bit of a way they do that. They're putting the big bangers on first. They've got the big one at the end as well that everyone knows for the encore. But what about the songs in the middle? Do they keep them the same throughout their kind of tour? Or do they mix it up and change it up just to keep things interesting? And what about when they've been gigging for years and years? Don't they really want to change things up? So we looked at that data. Luckily enough, Setlist FM collect that data. It's crowdsourced. You're able to get hold of this data and with a bit of web scraping, pull this down and start looking at the order of every gig that every band's played. So the bands, the data we get out of that and the bands that are perhaps doing the most similar gigs time after time, we created this measure, we call it the set similarity measure. If it's a 1, it means that lots and lots of gigs on average are the same as the last one they played. If it's a 0, it means they're really changing things up and no songs are in the same order at all. And you'll see that, perhaps no surprise that bands like Iron Maiden, Rush, some of these kind of big set-piece bands are putting on some really big gigs. They're putting on some big gigs with a story to tell, and those are the guys that have to keep things the same for reasons of kind of making it sensible when they're delivering it. What about the other end of the spectrum? Who's really mixing things up? Well, Grateful Dead, perhaps unsurprisingly, there's a bit of a myth about the Grateful Dead that they never play the same gig twice, ever. And we looked into the data and we found about 3 instances where that was the case. Now, 2 of them were on the same night, one after the other. So being crowdsourced data, this is perhaps a data error, but there is certainly 1 gig where they've repeated themselves. So let's put that myth to bed straight away. Humphreys McGee, never heard of them, but if you look at their Wikipedia page, they do all sorts of crazy things night after night. So they're definitely mixing things up. And so let's go into Tableau and explore this data a little bit more, which is exactly what we did. So here we are. This is the first kind of view that we used, a small multiple chart. Let's bring that up and just close down my slideshow. So here we are in Tableau. This is a small multiple chart. The red numbers show the gigs that were the least similar to the last one, the blue numbers, and we've put loads of bands on there. It's great for exploring the data, but perhaps not communicating. Likewise, this is a timeline chart showing the gigs one after the other, and again, we've ordered it by the ones that are least similar, so Humphreys McGee works there. But didn't really work for us, so instead let's build something out that really works and shows all those bands that we can communicate out to an audience. So I'm just going to use the difference measure just here. Let's average that set similarity measure. And let's look at the number of sets that any given band has performed and drop that band name onto here. Let's make that full size. Change it to a circle. And perhaps we could put something like the average set length on size. So the number of tracks on average that they're building out. Let's label the band name. And you can see up in that top right-hand corner, we've got bands like Alice Cooper, Def Leppard. They've done huge number of sets, and they're all fairly similar. Bob Dylan down here has done lots and lots of gigs, the most gigs that we've got in our data set. And he's mixing things up all the time. You've got Humphreys McGee down here as well. If we do some clustering on this, we can start to put these bands in different buckets. So I'm going to put them into 7 clusters here. So what Tableau's done there is created me clusters of these bands, and you can see that you've got gigs, bands doing gigs like all these up here. We've got the outliers, Bruce Springsteen, Bob Dylan, who are mixing things up, who've been doing this a long time. Now, I want to explore these people who've been doing things a long time. I want to look at those, the bands who've been doing lots and lots of gigs and look like they're keeping things very steady. Let's see how their career plays out over time. And I'm going to channel my inner Hans Rosling as this Bob Dylan starts playing more and more gigs over time. So he starts at the start of his career in 1952, and here we go. We've got some other bands start coming onto the chart now, and they all start off down here doing all sorts of kind of very different gigs, mixing things up. But we see very quickly they start getting more and more similar throughout their career. They're delivering the same sets over and over again. Perhaps Bruce Springsteen is starting to level out, and we see Bob Dylan, as he goes through his career, starts to do things, mix things up more and more and more as he comes down here, and he'll eventually end up on a path that he's done all these gigs and he's mixing things up more and more. But as a viewer of those gigs, as someone going to those gigs, how different were they? Let's explore this at perhaps a gig level. And to do that, I want to kind of step into the Rolling Stones. This is a band I grew up with. My dad was always playing these in the car. And I've used the transparency feature Francois showed yesterday just to put that on there. And we can see that you've got some gigs around here, sort of 1982. This was their Tattoo You tour, where it was perhaps the most similar gig after gig on that tour. They were churning out the same stuff. Versus down here, their Live Licks tour in 2002 was very different. What was it like going to those gigs? If you went to every gig on that tour and played perhaps as the Stones, how different was that? Well, we can explore that too within Tableau. So I've got some data here on the Rolling Stones, and I've got the order that they played those tours. So first of all, let's filter that down to the tour level, and let's start looking at that Tattoo You tour. And let's change that to a drop-down so I can see that later on. Now, I'm going to look at the tour set order. Let's make that continuous. And also the song order within that set. Now, when I'm looking at song orders, I want the first song they played to be at the top. So I'm going to reverse the axis. And now let's look at the songs that they played. So we've got the title here. Let's put that on color. And you can see for this Tattoo You tour that was perhaps their most similar, they almost always played Under My Thumb to start with. They almost always, apart from that first gig down here, played When the Whip Comes Down. Well, let's turn that into a line chart and start to explore that a little bit more. If we make the set order discrete, we'll get rid of some of these jumps where they didn't play a particular song. So we can see that this really was a similar gig. There was very, very little that changed throughout the tours. Gig after gig, they were doing the same thing. Let's compare that to the Live Licks tour. Wow, totally different. They're changing things up. You know, this they sometimes played Street Fighting Man first. They sometimes played it last. They were really enjoying themselves on this tour. This is perhaps the point within their career they were really enjoying themselves. So this is what we do in Tableau. Let me switch back to our presentation. This is what we do in Tableau. We take data, we explore it, and we start to answer questions like, well, what happens to bands? How diverse are the gigs, and how do they put together their gigs? The answer to that question was, you can see that kind of diagonal line almost formed in the data, with the exception of Bruce Springsteen, Bob Dylan. You've got bands that are generally, the longer they go on, the more similar their sets get over the course of their time. So they're starting to churn out the same things. Like I say, this is what we do. We take data, we question it. We then, having had that idea, we get the hold of the data, we do some analysis and insight within Tableau before communicating it out through a blog. It doesn't always work like this. This is actually what the process looks like. We hit a few ghosts on the way. We have to turn around. We have to revisit the idea. We then go back into the collection, a few more ghosts. We're hitting ghosts all over the place, trying to move through and just trying to finally get to a point where we're trying to communicate that out. It's not a straight line process. So welcome. Welcome to our talk about the hidden data behind everyday questions like those. I'm going to introduce my friend and collaborator here, Mr. Rob Radburn. Rob Radburn is the Kurt Cobain to Leicestershire County Council's Nirvana. Rob is, I think he'll be the first to admit, and Kurt wasn't the best guitarist in the world, but he was someone who wrote songs that he wanted to hear, that he wanted to tell, and he was probably held up as one of the greatest storytellers and songwriters of our time. And Rob, over to you.
Thank you. So Chris is basically saying I'm not very good at Tableau. So, and that's fair enough, because I don't think you have to be very technical to be very creative. And to continue the rockstar theme, this is a band I sort of grew up with. This is very political, very angst-ridden. He was one of my heroes when I was about 17, 18. And he's recently been interviewed to say, what's it like to be a guitarist for a band? And his view on being in a band and writing songs is very similar to my view of how to use Tableau. He said, I'm not a guitarist, I'm a songwriter who uses a guitar to write songs. And that's how I feel about Tableau. I may not know all the witty tricks, but I know how to tell a story with Tableau, and I think that's really important. So let me introduce my friend, fellow Zen Master, and my account manager, Chris Love. And as he's given a dead rock star reference, I shall return the favour. And I see Chris as Jimi Hendrix. Okay. Chris is a genius at Tableau. I think he's one of the best, probably the best in the world. He's also an Alteryx ace. So he's amazing at calculations, and he's amazing at design. He also works for a super group. He works for the Information Lab. So they have about 100 Alteryx and Tableau Zen Masters almost. So he's got this rich pool of talent around him that's, he can feed off. So the question is, we're coming from two different areas. Why are we working together? Now, if I can be so bold, I want to draw parallels to the Stones analysis that Chris started off with. There's some parallels to their career and to our careers in the Tableau community. We've been in this community for a very long time, it feels, probably 2011. And we've become like a board band, touring the same songs to the same people, saying the same things. And this is how your journey in Tableau usually happens. You start off in your first year, you're an eager pup, and you're showing tips and tricks to show how brilliant you are using Tableau. Admittedly more Chris than me. And then you realise there's a huge community out there, and the second year you engage in all the community events that are now available. So for 52 weeks in 2016, I did every Makeover Monday. Admittedly, it nearly killed me, but I did every Makeover Monday. So you get into that community, and then you get a bit lost. You get a bit lost repeating yourself. You feel like the Arctic Monkeys. You feel like you need a new direction to feel yourself. Yeah, AM was a great album 5 years ago, but you can't face doing that again. I recognise that we can't keep doing tips, and we also recognise that you guys coming after us are doing design and doing amazing stuff with Tableau, and I can't really compete. Our epiphany was in America last year when we watched the Freak-alytics guys talk about how they work. And it taught us to think differently, to use our skills differently, and to try and actually say something interesting about the world. It also told you to find your genius collaborator. And as it happens, I was working with a genius collaborator. So as a supergroup, we came together to create some concept albums, which we like to call curiosity-led data journalism. Now, we call it this because data journalists would get very annoyed that we even consider ourselves to be data journalists. But it's been explained much better by a fellow Zen master, Mike Sonaris, when he calls it citizen journalism, rigorously researched and presented directly, not overtly stated, but the facts of the matter determining our position. We published this as Data Beats on Medium. And when we came about thinking around what to call ourselves, that was a big decision, we thought Data Beats would be like the Beat Poets. Okay, we were bohemian hedonists celebrating non-conformity and spontaneity. Or was it about that data is the heartbeat of what we do? Or was it because we thought we were a couple of deadbeats and we're desperately trying to find that final album to be successful? So this is what our current set list looks like. These are the articles we've published over the last 6 months. It's what you expect middle-aged men to be looking at, I guess. Music, films, shopping centres. And this is what we've got coming up over the next few weeks, few months. Again, the other obsession of middle-aged men, park runs, nostalgia, now what I call music. And Chris is doing a searing investigation of agony art chart columns, Deirdre versus The Guardian's Pamela Stevenson. So that's what's coming up. Okay, I think let's move on. Let's have another story. Chris, why does it always rain on me?
Thanks, Rob. So I don't know if you're anything like me, you'll spend a lot of time in this app on the BBC. I seem to spend my life in this website, looking at, when I'm going camping, I'm spending time looking at when the rain's going to start, so I know when to pack away the tent. And the weather always tells me that it's going to start raining about 12 o'clock, so I think let's inch out every bit of this this Sunday morning before I have to put away the tent. And before you know it, the weather forecast has gone and changed. It's gone and moved, and suddenly it's going to be raining at 10 o'clock. You've got to whack away the tent as quick as you can. It gets wet, and before you know it, you're putting it back up in the back garden when you get back. I recently gave this talk in California, or a version of this talk, and they had lots of blank faces when I was talking about rain. So it's nice to be back in London, where people actually get that. And so Rob and I just talked about this. We were talking about the fact we're always in this weather app, and it's never right. We said, well, does it actually change that much? How often is the weather forecast changing when we're doing this? So again, we said, let's get the data. This is actually a HTML page that you can look at and start to pull out the data. Any HTML page that is driven like this by data will contain some clues where you can start scraping that data out. Here we are just identifying the tags that do that. So you've got the kind of the class day name that identifies where that day label is. You've got the span title. If you look for that, every time in that HTML page, you will find what the weather's going to be at that given hour. And once you do that and separate that out, then you can start to turn that into data that we can use. Now, as Rob mentioned, I'm an UltraXA, so I chose to do that in UltraX. We chose to look at a number of locations. So at the top left there, I'm bringing in locations from Oadby and Kimberley in Nottinghamshire, where Rob lives in Leicester, I live in Kimberley in Nottinghamshire. So we chose to pull down those two locations. We looked at Edinburgh, Cardiff, London, and Manchester, because I used to live in Manchester and it's wet there. It's always raining. So we thought that'd be interesting to look at. We parsed that data using regex, so those green tools in the middle in UltraX are bringing that data down, parsing out those patterns that we see in the HTML, and before just doing some quick preparation on it to get that down. And this is what you end up with. You end up with a table of data. Now, I sneaked this onto our UltraX server and ran it every hour for about 2 months, pulling down data for each of those locations and looking at how the weather forecast changed hour by hour. And we pulled things like you can see, the wind, the humidity, the pressure, what time the weather forecast was, and what icon the BBC used to show that weather. And so we put it into Tableau. This is a a chart that shows a given day and how the forecast changes over time for that day. You can see that, yeah, it changes quite a lot. We've got cloud going back to light cloud, sometimes going to sunny spells as we move down for that given hour. And so if we take out, using a last calculation to filter out those looking previous value to those calculations, we can see these are all the times that weather forecast is changing as we move down across the hour. And so we can start to then count how often does that change for a given day. And this is what happens. Well, the weather forecast starts off every 4 hours, so we get those 4-hour chunks. And every time the weather forecast changes, we're going to count and add on 1 to that value. And you see we get up to 30 changes over time. It's going to start again, but we're getting up to 30 changes in the weather forecast for any given hour. So, yeah, kind of our idea, our hypothesis at the start of this process was right. And how does that change over time? We turned it into a percentage to say what percentage of the weather forecast represents a change from what it was in the previous hour. And you can see some bits there. You can see Manchester at the end of November when we did this analysis got very difficult to predict. It was changing well over 30% of the time that weather forecast represented a change. Cardiff at the start of December was a little bit easier. The weather forecasts had a pretty reasonable time and kept their weather forecasts fairly static during that. So this is what we do. We look at data, we bring it together, and then we publish that and try and write it up into a blog to turn those charts into some analysis. But before you get to the point of thinking this is all about me and the stuff I do, let's let Rob talk you through another example.
Okay. So in the 80s and 90s, growing up and going to shopping centres, they all seemed to be the same. It didn't matter where you went in the country, the shops were the same, they looked the same, they were called the same, they were called Arndale centres or something like that. They was always the same. And you know, I have 3 children and I don't get out much. And over Christmas, we went to a shopping centre. And this is St Albans, lovely town of St Albans. We was there to see Harry Potter, I think. And I was walking around, you know, somewhat cluelessly. And I didn't really recognise half the shops. Okay, they looked completely different to me. Some of them I assumed were only online shops. Now, admittedly, I was looking for Woolworths and Our Price and things like that, and clearly the world has changed and moved on. So it just got us thinking a little bit. You know, and Chris was sort of doing the same thing around Christmas, you know, when we was talking about this, you know, what's happening. So are all shopping centres the same? So, you know, we thought about that. I don't use Alteryx, and so I used a free tool called PassHub. There seems to be a lot of money in making, in retail data, but there doesn't seem to be any free data sets available. So we had to pass this from all the major, scrape it from all the major shopping centre websites, which are uniformly awful, impossible to navigate. And we also found a reasonably amusing problem, which was, this is the 3 store, okay? It's 3, or it's the letter, number 3, or it's called the 3 store, or they just give up and call it all 3 things. So when you get across that, to do this sort of stuff can be a lot of time looking at the data and manually changing it. So I spent 2 weeks just after Christmas literally going through a spreadsheet trying to align whether these stores are actually the same or not. Okay, so the analysis started from this colourful stacked bar chart. I read a lot of articles on retail, which again, uniformly dull. And one of the things that stood out was that in the past, you needed a minimum of 250 stores to have a UK-wide coverage. And that sort of model had been somewhat broken a bit because of the internet. You didn't really need 250 stores. So basically what this graph is showing is the size of the retail chains in each shopping centre. The blue is basically showing that the stores there, that they have 0 to 5 stores across the country. The outlier, and I can't really do a Hans Rosling thing, is down the bottom is the Merrion Centre, which has a very high percentage of stores that only have 0 to 5 across the country. If you look at the purple, that's basically showing chains that have more than 30 to 35 stores. So what I got from that was actually, it wasn't dominated by the big chains anymore. There was a bit more of a mix of shopping across the top 38. Another way of looking at this, and another way to engage people in terms of an article, is to try and do one of these. This is a spatial tree map, and it's showing the unique shops in each of the shopping centres. It's spatial in the sense that if you look at Derby in the middle, Derby's in the middle of the country. If you look at blue water down the bottom, blue water is at the bottom of the country. It's spatially arranging the data, okay, so in terms of its geography, sort of roughly. And within each of those areas, the square is a shop, okay, from A to Z. And I think what it's basically showing is there is a lot of unique shops across the country, that the retail experience can be quite different. I've spent a lot of time building tree maps over the last couple of years. Okay, so I'm sort of obsessed with it. So these are a couple from this year. I seem to try and do one a week. And I think it'd be a good opportunity now to try and demystify how to do this, because it seems very, very difficult. People ask me, it must be very complicated. And actually, it's incredibly simple. I stand on the shoulder of giants. This is the work by the GI Centre. They created the algorithm. I was fortunate enough to work with these guys for a year, about 10 years ago. So I'm basically using their work. And I need some help, and as I'm not very technical, Chris is going to press the buttons. The first thing I want to show is how you need to get the data ready. It's very simple. The data needs to be set out this way, so the shop's on the left-hand side, and then I just have the easting and northing, or the westing and northing of the shopping centre, and I just repeat that down for all the shops. Now Chris is going to...
Switch out the...
Hopefully you can still hear me. So I'm not very technical. I'm not a programmer. I'm a Google programmer. This is using a piece of software called Processing. Processing is free. It's based on the Java platform. It's used by artists and graphic designers, mainly the artistic community, to build major installations and visualizations. Not really data-driven necessarily. There's a lot of code here. I don't understand much of that code. All you need to worry about is that it needs to read some data, and my assistant will show you. And you need to tell it to be spatial, which is Chris. So that bit there. So I want this to be a spatial tree map. And at the bottom, you've got the option to give it a text file or a shape file. Okay? CSV, you run it. Chris is going to run it. And we blag for some time because we don't know how long it's going to take. It's taking a bit of data to process this. And there you have, there's a spatial tree map from a very simple CSV to an output.
Shall I go and find that?
You can do.
And let me open up a Tableau workbook to put it in.
So we have a shapefile, and as we all know, Tableau can take a shapefile natively now. So Chris is going to drag and drop the shapefile over to Tableau.
Yeah, look at that.
He hasn't paid for his license. How embarrassing is that? Come on, Chris.
Come on.
Come on, man.
There we go.
Okay. And then, really complicated in Tableau, to build this out, Chris is going to double-click geometry. And then we have a map, because it's a spatial geography, so Tableau sees the map. And we're going to do a very technical thing to get rid of the map.
Wash out.
Let's wash it out. Okay. And then because it's bringing in two geographies, we just need to, so it's got the shops and as well as the supermarkets, so it's two geographies. We need to get rid of one of the geographies because Tableau doesn't understand layers at the moment. And then if we just bring on the shops, which is handily called label, and bring it on to colour.
Or colour. There we go.
There you go. Very simple, incredibly powerful. As analysts, I think you may want to use that day to day if you've got got geographical data. Okay. Want me to sing?
There we are.
Okay. So there's 3 examples of Data Beats articles. But what you're really here for is the takeaways. What can you guys learn from our last 6 months? Let's start with questions. Okay, we've got this 4 process. Let's talk about questions. When we started this, I talked about us trying to find almost the truth about the world. But as Joe Strummer said, you can get a long way with vague ideas. And the vague ideas have come from us talking about stuff that annoys us in life, maybe, or we don't understand in life. But it also comes from everyday occurrences. So every time I read a Guardian article or a Telegraph article, there's just loads and loads of data in there. That story is data-driven. And we can use that to tell stories. And we're also reasonably confident in our Tableau skills that we can tell those stories. But we've got to be honest that these stories are around what two 40-year-old blokes are interested in, so they may not be exactly what you guys are interested in. And when we sat down to think about ideas, we thought that ideas was like this. It's all about the new ideas. You know, that's what we do as analysts day to day. We come up with new ideas around the world, new data sets. Isn't that always the way? Isn't that how we do things in a day to day? And then we thought about it a bit more and we thought, nah, it's not, is it really? Because the stuff we've been talking about today, everyone knows. You know, why is the weather not right? Do bands play the same songs? These aren't necessarily new, unique questions. And it's a bit the same at work. You know, we know that staff turnover is killing our bottom line. That's not a new story or a new idea. I think the new idea for us now is actually getting to the data. Okay? Collecting the data to answer that question, because you can't really have a conversation around that problem unless you have the data. So I guess what we're saying is that don't be afraid of existing ideas. It doesn't always have to be shiny and new to be interesting. Look for those accepted truths that you all have. And if you want to communicate the idea, it is all about the measures and the quantities. The idea isn't the most important thing in this process for us. It's actually collecting the data and then communicating that data. So Chris is going to talk about a little bit more detail around how we collect data.
So it would be really easy for me to stand here as an UltraX ace and say that, yeah, you should use UltraX to collect that data. Isn't that part of what I do every day? And yes, to a degree, I use UltraX to collect this, but Rob doesn't know UltraX. And he's clearly going off and collecting some of this data too. So which tools have we used throughout this process? Well, yes, we've used UltraX. We've used ParseHub to web scrape and scrape down that data. We use EasyMorph sometimes to extract that data and prepare it and get from spreadsheets and pull things together. We've used Excel to prepare the data and go through it manually and edit things. And there has been a lot of manual collection throughout this process, just sitting down and having to churn through, sometimes for weeks, to look at what this is about. And one thing that we're really excited about is Tableau Prep. I think for Rob and I, as people who don't necessarily use the same tools to do that, Data Prep, Tableau Prep, gives us the opportunity to collaborate for the first time within a tool, to be able to speak the same language and work through that as we need to. But how do we know when we've got the right data and the right things in place? For the weather stuff, it was fairly arbitrary that I decided to look at that every hour. It was fairly arbitrary the locations we chose to look at it. We decided to collect it for 2 months. Again, that was fairly arbitrary. And yet at work, we always hear when I'm out with customers, people always ask me about single source of the truth. Why are the two things different? Why in the work we do offline are we happy to just be fairly arbitrary about the data we use and make decisions around it? But at work, we're pushed towards having set data sets that tell the same story. I was with a customer the other day, and they were asking me, they were from their HR department, and they said, Chris, we at the HR, we're always looking at our levers, and we're always looking at the staff retention. And we do that on a daily basis, and we collect data on that. And yet, in finance, they look at it, and they need the average per month, the average number of levers per month, because that's what's important to them. How do we resolve those two things and get a data set that works for us? And my honest answer was, you're doing two different things. You don't need one version of the data that tells you that. You can take this data away and approach it from two different angles, because that's what I do all the time. We're making those decisions and pulling that together. And the same can be true of analysis. Data analysis isn't meant to be perfect. We're making decisions all the time about the data analysis as we go through it. It doesn't have to be perfect. When I'm doing data analysis at work, or for data beats, or through any kind of process, then I'm making decisions about how long I spend on it, the accuracy of that process, and the story that I want to tell out at the end. Now, clearly, if I invest more time in getting really accurate data, then it's going to take me a long time. And if I spend time trying to get that, then I might lose some of the story on the way, because it's really going right down into the detail of that data. One example was that set list data. I kind of glossed over the measure we created there. And there were a few ways that we could have done that. We could have looked at set lists and said, do they always play a certain song at a certain time in a gig? Let's look at that and use that. That would have been relatively easy to do. The other kind of opposite end of that scale, looking at kind of getting a really accurate measure, was to compare every set list and how does that relate, every song in every set list, and how does it relate across the whole timeline of when that band's been playing music. But that's going to be really hard, and it's going to result in a lot of data. Clearly there needs to be a middle ground, and whenever I'm looking for answers like this, again I turn to Google. There was a blog post on the Kendall Tao method that I eventually found. Now, I don't want to go into this in too much detail, but basically if you look at two subsequent gigs, you're able to say song A and song B in gig A versus the second gig. Were they in the same order? In that case, we'll put them as concordant pairs if they were the same across both gigs. If they're not in the same order, if song A becomes before song B in gig 1, gig 2, they're in the opposite order, we'll make them discordant. And then you add that up, and basically that's where that measure of 1 to 0 comes from, by looking at all the songs in subsequent gigs. We're only looking at subsequent gigs. If bands play the same songs in the same order at odd-numbered gigs versus even number of gigs, they're going to come out as a 0 on our method. It's not the most accurate method, but it's something that I was happy doing. I spent long enough. You know, Rob was coming to me throughout this process saying, Chris, we really need to get this article out. Can't you just do this the easy way? That was my personal decision. I wanted to do something a little bit more complicated, to be able to make sure that I was telling the story. And as analysts, we're always having that battle between time and accuracy and story. That was really something that is very personal to me, and I think it's something that to be aware of when you're spending time in any data process. How much time are you willing to spend on that? How important is the story at the end of the day? How much value is your company going to get out of that story when you tell it to your managers? That moves the conversation down, and you can decide how important that is and how much time we spent. Now, Rob, to finish, over to you.
Okay, the final slide about communication, the final part. Writing about visualization is incredibly difficult, we have found. And it's a stupid thing to do in some ways, because it is incredibly difficult. It's not like you can do a viz and you can send it out there, and if nobody understands it, you can say, well, it was just a bit of fun. I learned something and I'm just putting it out there, and it's a bonus if anybody likes it. And that's what a lot of bands do when they do their concept albums. It's just for us. I think when you do writing about visualization, if you put something out there that makes absolutely no sense to anybody, you can't hide behind that. And over the last, say, 5 or 6 years in the community, I haven't really spent a lot of time looking at the data and trying to make sense of that data. And writing is really difficult. Some of the stuff, it takes us a lot longer to do the writing than it does to do the visualization. And we tend to try and do it in drafts. One of us will write the first draft, and then the other person will tear it apart and say, this doesn't make a lot of sense, Rob. And then we'll try and bring it back together again. And the other thing is that because we're using Medium, there's two things. Firstly, we're trying to break away, dare I say, from the data viz Tableau community bubble and trying to put stuff out there for a wider consumption. And also, it's static. It doesn't allow us to embed Tableau public visualizations in it. Yeah, it has to be a link. And so you have to really think about how you communicate stuff that, when you've done the analysis, is pretty obvious, or you're pretty sure that your community will understand it. And this is a good example. So this is a story I wrote about inequality in this country, and a link to Sam Allardyce. Read the article the link. And I put this in as a slope chart, which is a very classic Tableau way to show the data. And then Chris was saying to me, well, does everybody understand a slope chart? It's like, yeah, of course everyone understands a slope chart. But then it did get me thinking, maybe they don't. How do we construct it? So we decided to deconstruct it, like as in cooking. Cookery seems to be very keen on deconstructing food. Let's deconstruct a chart. So we started off by showing the chart. Here it is. On the left-hand side is the highest 10% and what they spend their disposable income on. On the right-hand side is the lowest 10%, what they spend their income on. And we just broke it down and we explained every step. So yeah, there's two axes, one for highest, one for lowest. And there's two different groups there. Then we put some dots on it, and that tells you how much they're spending compared to that axis. And we labelled some of those dots because the poorest 10% of the community, this is what they're spending more money on. And then we drew it together to show that relative change. I don't want to get too political, but there you go. It's reasonably disgraceful that the lowest 10% have to pay a lot more for their housing and basic needs than the top 10%. That was our final slope chart, and it just sort of told the story in a much easier way and a much clearer way for us. And again, it got us really thinking about the difference between exploration and static imagery. Because a lot of the work that we do is exploratory, rightly so. Tableau is that tool. But sometimes it feels a little bit of a cop-out where we put something out there to people and say, well, you go and find your own story. I've given you all the tools, you have all the parameters, you find your own story, it's in there somewhere. I think that's okay to a point, but at some stage, surely we have to, understand the data ourselves and try and communicate what that data is. As I say, medium is static. So people are just going to see that image. And when you do Twitter, any of your stuff on there, no one clicks through to your Tableau public vids. They're only seeing the image. So it just got us thinking about you have to work a lot more harder with static visualization. It needs more commentary and more analysis to support that. And you are absolutely required to communicate your story. And it is incredibly difficult, I found. Okay. So there are the 4 stages to write a Data Beats article or to visualize and communicate. How you use those 4 stages will depend on you, on how you work. Let me explain with a story. This is Hallelujah by Leonard Cohen. This is imprinted on our minds, I'd argue, through every single X Factor and wannabe star singing Hallelujah. And it's a classic song going back to the 1980s. Unfortunately for me, I had to admit to my children that the first time I ever heard of the song was watching Shrek, the hipster that I am. Hallelujah, it's just an amazing song. It's played at every wedding, I'm sure. Its history is very, very interesting. If you listen to Malcolm Gladwell's podcast, Revisionist History, which I recommend, it talks about how this song developed. Cohen took 5 years to write this song. He started in 1984. But it wasn't really until John Cale saw the song, heard the song and did a version of it. By that time, Cohen had written 15 verses of it and he wasn't too sure which verse to use. John Cale looked at the song and made it much darker. And that was sort of the accepted version. But everybody's real version of Hallelujah is Jeff Buckley's version in 1994. So he changed out to the guitar and also had an amazing voice. And he unfortunately died. And that sort of made the song more popular and more well-known. It took 15 years of changes. And effectively what we got is Buckley's version isn't a version of Leonard Cohen's. It's a version of John Cale's version of Leonard Cohen's version. It's taken a long time for this song to get to be imprinted on our minds. You compare that to other songs. You compare to R.E.M's Losing My Religion, which took 10 minutes to write. If you look at Yesterday by Paul McCartney, Beatles, that took him 1 minute to write. And of course, if you look at George Michael's Last Christmas, he did that in an afternoon. So the classics don't take long sometimes. So there's an interesting, how do you work, how do you viz sort of analogy going on here. And there's an economist called David Galson, who's written a number of books about the creativity of artists across mainly painters, but certainly musicians. And he has this idea of conceptual innovators versus experimental innovators. The conceptual innovator, they work quickly. They have very specific ideas. They know what they want to communicate and they're going to do that very clearly. And I would argue that is, in our community, Makeover Monday. Okay, so I did Makeover Monday for 52 weeks. I never did it on a Monday. I never got anywhere near getting it done on a Monday. It was always like on the Friday or the Saturday. I was working really, really slow, and I just didn't have any really ideas, and I was really restless with what I was doing. And that's because I'd argue I'm an experimental innovator. I never have a clear idea. I can't articulate it very well, and when I start, I don't really know where I'm going, and it's trial and error. And I think that's what we're doing. The other thing about this continuum is that the conceptual innovators tend to be younger. So think Orson Welles with Citizen Kane, which he directed and wrote at 25, compared to, say, Mark Twain. He wrote Huckleberry Finn when he was 50. So there's an age thing here. And why is this important? Well, for two middle-aged men, there is some salvation here. Creativity isn't just for the young. Daniel Pink said that it will bolster the resolve of the relentlessly curious, the dedicated tortoises undaunted by the blur of the hares. This community has a lot of hares, and sometimes it feels very difficult to keep up with. But when it comes to vizzing, it's okay to be a tortoise, because it doesn't matter how slowly you go as long as you do not stop. Thanks for listening. Fill in the survey. We're not going to take questions if you want to come speak to us afterwards. Thank you.